is on the slide, scripting GDB. There are at least two scripting interfaces for GDB. There's this old traditional, very primitive macro facility that GDB has. Only supports set, printf, while, if, and else. Recent version of GDB, although they don't seem to be yet part of most standard Linux distributions, I have to say. Recent versions of GDB also support scripting GDB using Python. And such scripting is much more powerful. So there you're using Python to control the actions that GDB takes. When it starts a program, it sets a breakpoint. When it continues to a breakpoint, you can use it to examine the program state and do more sophisticated things. We've used GDB scripts before in, so they're being widely used in kernel debugging. There's a set of macros, for instance, to debug the OS 10 Darwin kernel. I wrote a number of macros that students can use to debug our Pintos kernel. And for example, one of them is a GDB macro that allows you to examine a list. So this walks through a list and looks at all values. That is shown here for dump list. And what this macro facility basically does, it uses set, which is simple assignment, and then it consists of C expressions and C expressions here. And in essence, you can script in a programmatic fashion what you would otherwise type at the GDB command line. Okay. So just like I showed you, print p arrow next arrow next arrow next, you can write a script for that. This is a script that iterates through a list. Okay. So I start out with a list element. I say while I'm not at the tail, I'm advancing one, outputting it and then advancing the list onto the next one.
What if your script has a bug?
If your script has a so it is in fact the case that, let's say the script has a bug and you are accessing something that would lead to an invalid memory access, okay? And the script stops at this point. Then the state of the program is in fact as if you type those commands and stopped at this point. And this can be a problem sometimes, in particular if you write advanced scripts that actually change the state of the program. Okay, so what I have mentioned so far is in GDB you can also alter the state of the program. You can change variables, you can call functions in fact if you want. And if some of your macros change the state of this, then it's a problem. I'll show you one example here. So here we're using a script whereby we change the state of the program in that we're setting ESP, EBP, and EIP. Okay, here. Now we've saved the old values, right? And after we're done, we are restoring them, right? But if something goes wrong here, as it sometimes does, then those values have been corrupted, and in fact, then this particular script here does not work. Yeah, so that answers your question. The key is that you interact with the actual program state as it is when you change your make will be affected. I think I spent 1.5 hours. I want to give, how about we do this? I give 2 or 5 minutes for questions, which is all material by GDB, and if there are any, and then we allow people who want to go, who want to leave, can leave. And if anybody is really hardcore, I could show how to use GPROF. So questions about what I've talked about so far, Valgrind, GDB.